Informational organization operates between two absolute poles. On one end, everything, the state of infinite entropy containing the superposition of all possible histories. On the other, nothing, the radical absence of all context. The topic ledger theory adopts a contextual ontology built on the axiom that context mathematically precedes content. For perception to occur, the infinite potential of everything must be quantized into discrete, bounded subsets. These localized contexts are defined as topics. Existence begins with the initialization of a computable data structure called the universal ledger. This directed acyclic graph records every collision and interaction between these bounded topics. Reality is the aggregate computational output of all active ledgers currently flowing from the state of infinite potential. This framework allows us to reverse engineer the formation of the universal ledger, starting from the absolute void and building up to macrocosmology. We begin by tracking the initialization process, where a genesis operator breaks the symmetry of the absolute void. Next, we calculate the game-theoretic consensus rules that dictate how independent topics negotiate to print events onto the ledger. Finally, we measure chronological complexity through the assembly index and map that depth to the entropy limits of the observable universe. Following this mathematical pipeline reveals the Lagrangian kinetic limit that prevents the universe's memory from collapsing back into noise. The topic ledger theory addresses the cosmological prime mover problem using the genesis operator. This equation defines the mechanism of distinction. When the genesis operator, d hat, is applied to the absolute void, it forces a mathematical symmetry break, resulting in a primordial magnitude. This isolates the seeded state, the first genesis block of the universal DAG. Breaking the symmetry of the void establishes a non-zero rate of distinction. In computational physics, this transition from an undefined state to a seeded state generates the universe's first unit of informational energy. This informational energy is the product of the rate of change and the magnitude of the distinction from the absolute void. This mathematical distinction from nothingness provides the foundational energy source for all subsequent logical operations. The universal ledger grows through direct collisions, intersections of context that require a strict mathematical resolution to determine the next state. Topics act as agents in these collisions, wagering their resources and physical stakes to influence the outcome. To quantify the causal weight of each topic, we apply the Shapley value from cooperative game theory. The marginal contribution term isolates exactly how much the addition of a specific topic alters the reality of a partial context. The consensus function sums these weighted inputs to output a final state for the ledger. Observable physical events are the negotiated mathematical compromises resulting from these game-theoretical interactions. Within the topic ledger theory, time is a function of the assembly index. This index measures the minimal sequence of negotiated events required to construct a specific topic. Time is the measure of the depth of the ledger. Because the ledger is immutable, we use quantum retrodiction to probe the past. Applying Bayes' theorem, we execute probabilistic searches through the collision chain. This conditional probability takes a measurement and traces it back to a specific bad block deep within the DAG's history. A structure only solidifies onto the ledger when its signal strength exceeds the inverse of its complexity, passing an all-or-nothing phase transition. Since every event requires an exact threshold of mathematical consensus, the universe's history is a forensically traceable computational record. Scaling these mechanics to the macrocosmos requires defining the minimal unit of time for one collision as the Planck time. We calculate the absolute depth of the universal ledger by dividing the current age of the universe by that Planck time unit. The cosmological assembly index is approximately 8.07 times 10 to the 60th power discrete events since the genesis block. Mapping this event depth into the informational phase space equation reveals a required search space of 1.05 times 10 to the 122nd dimensions. This result matches the Bekenstein-Hawking bound and the holographic principle, which set the maximum informational capacity of the observable universe at 10 to the 122nd bits. The constant pi/4 in these derivations represents the angular velocity required to rotate a state vector out of the absolute void and into a converged topic. The entropy limits defined by general relativity are the strict geometric boundaries of the ledger's phase space capacity. Managing a 10 to the 122nd dimensional ledger requires a clear architectural split between processing and storage. Any computable history needs an active medium for the consensus to date. High-energy photons provide the kinetic mechanism for these volatile processing logic interactions. For the resulting ledger to remain immutable, it requires a non-interactive medium for storage. Dark matter provides this stable sector, holding the stakes and memory of the resolved events. This relationship is governed by the kinetic mixing term in the Lagrangian, creating a coupling between the visible processing and dark memory sectors. A small, non-zero kinetic coupling acts as a security protocol, preventing the high-energy photon debate from corrupting the immutable dark matter memory. Quantum Retrodiction analysis allows us to define the stability limits of this kinetic coupling. Within this framework, causal stability is maintained only as long as the coupling strength, epsilon, remains below exactly pi radians. Reaching the pi radian boundary triggers a complete spatial inversion. At this point, maximum von Neumann entropy transfers directly into the dark matter. This theoretical limit represents the physical melting of the ledger, reversing the genesis block and returning all contextual topics to the void. The observable universe exists as a highly constrained, algorithmically bounded negotiation. Reality endures because its immutable computational ledger remains securely locked beneath the Lagrangian boundary of causal stability.